What's going on, Algebra Bros? It's Mr. C here, and in this video, I'd like to start things out with a question. Where does E come from? Well, I wish I could tell you the exact answer to this, but as far as I know, there are really just a lot of different theories as to where it comes from. One theory that has gained a lot of popularity over the years is that E is the result of more or less a thought experiment involving the formula for compound interest. So here's what the thought experiment entails. All right, so remember with the formula for compound interest, it goes A equals P quantity 1 plus R over N raised to the NT. I'm going to make a little laundry list of things here to the left involving the variables. Let's say we don't know what the ending amount is, but we're going to start with a principal value of just $1. And we're going to use an interest rate of 100%, or in decimal format is just the number 1. We're going to allow n to increase without bound, or we're going to allow n to go to infinity, meaning that we're going to compound this 100% interest an infinite amount of times throughout 1 year using this $1. So if we plug all this information into the formula for compound interest, we get A equals 1 times 1 plus 1 over n to the n times 1. And that simplifies to 1 plus 1 over n to the power of n. Now what I'm going to do is insert this formula into my graphing calculator, and how I'm going to do that is as follows. I'm going to represent A by y sub 1, and the right hand side I'm going to use x instead of n, so it's going to be 1 plus 1 over x to the power of x. And so this is the formula that I'm going to use and define as a function in my graphing calculator. And I'm going to go ahead and get my graphing calculator out right now. And I'm going to go to y equals parentheses 1 plus 1 over x, close off parentheses, raise it to the power of x. And what I'm going to do is actually adjust my table in the calculator, namely some of the settings. I'm going to press second window and get back down, second window, and I'm going to go down to row 3 where it says the independent variable. Normally it just populates those values for us, but I'm going to have it be more of a manual thing. I'm going to arrow over to where it says ask, and I can leave the dependent variable as auto, so it's going to automatically calculate the dependent variable or the value of y sub 1 for us. And I'm going to go ahead and hit second graph to access the table. And now I can pick and choose different values of x, which, remember, these are really representing different values of n, or different values that represent the number of times that $1 is getting interest compounded. So for example, if x were 1, meaning that interest is just calculated one time throughout that 1 year, then we get a final amount of 2. If we compound interest, say quarterly, or 4 times within that 1 year, we get a value of 2.4414. So at the end of 1 year, the amount would jump up by 44 cents roughly. If we were to do, say, monthly, n would be 12. We get about $2.61. If we did it weekly, n would be 52. And you can see that these values of y1 are increasing, kind of a big increase at first, but now it's sort of starting to tame a little bit. We go from an x value of 12 or an n value of 12, giving us $2.61, jumping up to an x or n value of 52, which only bumps us up 8 cents roughly. If we were to do this daily, 365, not really a big jump from there. So if interest was compounded every day, that $1 would turn into $2.71. Now I'm going to kind of go a little cray with the x values here. I'm going to jump up to 1,000. So let's say interest is calculated 1,000 times throughout the year. What would happen to that $1? It would turn into 2.72-ish. Maybe if we chose it to be 2,000, 2.72-ish still. I'm going to jump up to an x value of 10,000 and see what the $1 would turn into. And so if interest was calculated 10,000 times throughout that 1 year, that $1 turns into roughly $2.72 still. And if you notice, the value there for y1 is 2.7181, and it turns out that the decimals would keep on going beyond that. Obviously, we don't have the space for it on the graphing calculator, but as you increase these x values, the y1 values approach the number e. And so we can see kind of like the birth of the number e via this thought experiment, where we're, kind of throwing ourselves in a very special case where it's $1, an interest rate of 100%, time value of 1 year only, and then we're increasing the number of times that the interest is calculated throughout that 1 year. And so what happens is, we reach some sort of limiting value in terms of what that $1 turns into, and that limiting value is exactly the number e. So like I said, this is one theory that has a lot of popularity as to where the number e came from, but truth be told, I honestly don't know exactly where the number e came from, but it's fun to think of it in this way. It's kind of neat to see the formula for compound interest kind of give rise to this number e, which isn't just confined to the financial world, but it transcends all disciplines, in fact. So kind of a neat thing, a neat discovery, and we're happy it's here. So that's where the video is going to end. Of course, if you have any questions about anything that I did or mentioned in it, feel free to let me know. Otherwise, thanks for watching, and I hope I instilled a little bit of excitement and motivation about where the number e came from. All right, thanks, Algebros. Take care.